Here we've got a free fall question where a small stone is dropped, spends 6 seconds in the air, and then it finally strikes the ground below. We want to know how fast it's moving when it finally strikes the ground, just before it hits. So once again, let's write all our given information down. We've got 5 variables: v initial, v final, acceleration, time, and displacement. Now with these free fall questions, it seems like there's not very much information. You certainly have to read between the lines when you look at these problems. When you drop a stone, we assume dropping means you're releasing it from your hand from rest. So v initial is 0. It spends 6 seconds in the air, so that's obviously our time. Notice the units match up. I've got meters per second and seconds. So far, so good. What speed is it moving when it reaches the ground? So we're trying to find v final just before it hits the ground. Now the acceleration for any object flying through the air, regardless of whether it's on its way up or on its way down, is always the acceleration due to gravity, which is always down. Negative 9.8 meters per second squared, the negative in this case meaning that it's down. Now we don't know the displacement, which would be how high the cliff is, but we're trying to find v final. So we want to avoid equations with d in it. So if we look at our list of formulas, this one fits the bill. V final is v initial plus acceleration times time. It's already isolated for v final, so we're off and running. V initial is 0, acceleration is negative 9.8, and our time was 6 seconds. Negative 9.8 times 6 seconds is negative 59 meters per second. That's my final velocity. And remember, it is a vector, so the negative simply means that it's down. Now, the question did ask what is the speed, and speed is the scalar version of velocity. So the speed, instead of writing it like this, where we've got a direction, we would simply say that my final speed is 59 meters per second.